Welcome to W.M. Berg's presentation on chains and belt drives. Today we'll be discussing W.M. Berg's light-duty transmission and power and motion control products. And what our current agenda will be is chains and belt drives. What's the difference? What is the term silent chain? When we talk about light-duty standard timing belts, what does that mean? Our W.M. Berg roller chain, our light-duty V-belts and miscellaneous belt and pulley and also bring some application examples in at the end of the program. So sprockets, gears, and pulleys, what's the difference? Sprockets drive chains, pulleys drive belts, gears drive other gears. We do have sometimes where people would think about, because in our catalog we actually have some people state it'll say a gear pulley or a gear sprocket, because people think of that, or they see the teeth on it, they think of it as a geared sprocket. But gears are different than sprockets. Also, by the way, to inform everyone that we just received W.M. Berg's brand new catalog. So if you guys want to send me an email, putting a request in the tech support email, we'll start sending out the new catalogs. They are about half the size of what they used to be. We shrunk them down, just make them a lot easier for our customers to handle. Sort of a throwback to the old style. So we can get back to that in the future. What is silent chain cable drive systems? Well, you'll hear a lot of the other people out in the industry saying that they were the first to have it. But the proof is that W.M. Berg patented silent chain technology in 1981, almost 33 years ago. We are the first people to actually patent the silent chain drive system. We also were one of the few people that patented timing belts back in the early parts when Gates did it. Gates went the heavy-duty route. We went with the polyurethane route. And, of course, Gates ended up as the big company they are today. So let's talk about our molded belts. Our molded belts are usually a molded polyurethane using a 90A durometer. We use a 303 stainless steel cable core, which is a wrapped stainless steel cable of various diameters depending on what type of cable we're looking at or what kind of belt we're dealing with. The nice thing about a lot of our molded belts is we offer a zero backlash. Except for the Power V and the Flexi Grips, all of those other belts are a zero backlash chain system. You wouldn't find that in a roller chain or in a lot of the other kind of chain applications that are out there. Another advantage of what I call a silent chain is it's lightweight, self-lubricating. You can do infinite lengths and pitches. It's field spliceable, so if somebody doesn't know what length they would need, they can always splice it in the field and make it their own size. We also have a thing called an aramid fiber core. That's the same thing as Kevlar. The belt is derated by 50%. The reason of the derating isn't due to the cable itself. It's actually due to the lubrosity of the aramid fiber and the crimp we use. We haven't been able to find a way of crimping them better than just a stainless steel sleeve that's crimped around it. But the lubrosity of the belt itself becomes a point where under higher tensions it can slip out of the crimp, and that's the weakest point of most of these belt systems are the crimp areas. So when you deal with things that you might see small kinds of flaws within a belt application, the weakest point in my experience and most of the thing is coming out of the crimp areas, and those are the ones that should be most paid attention to if you have a service issue with these kinds of belts. The nice thing about aramid core belts is they also provide you greater flexibility. So if you're dealing with a sprocket that has less than, let's say, an inch and a half or even an inch of diameter, the aramid core becomes a very nice application for that, because going around that belt, it's sort of like using a wire hanger and bending it back and forth, back and forth. The stainless steel over a period of time might have a tendency to split, fray, and break. With an aramid core, it's because it's a more nimble type of material, it will wrap around the around the sprocket, smaller sprockets better. It also gives you a better temperature properties under extreme temperature variations. A perfect example of this is a lot of our belts are used for the window shade units on, let's say, Learjets and other business-type aircraft. We were actually selling them our standard stainless steel core belts, but as the progress of jet aircraft has changed, they've gone from regional to Atlantic or cross transcontinental flights, which have caused them to go from a ceiling of 40,000 to 50,000 and higher, which has caused the temperatures that these are running at and soak temperatures at much higher rates where they're minus 20 or 30 below for longer periods of time. Because of going with a steel belt, it became a moisture where the belts were freezing. With the Kevlar or the Aramid fiber, it doesn't have those same kind of properties that would bring the moisture to it. Now, when we talk about our molded belts, some of the things let's get into is the FlexiGear JCS, examples of the GCS series. The FlexiGear belts are mostly being known as the ladder belts. The sprockets can be machined to the Agnes specs. They're double spline, so they allow for higher loads. And what I mean by double spline is, like you see in the picture, you've got a ladder belt. They're available in our three pitches, which is .0982, .1, and .130 circular pitches. So you can see the advantages of the ladder series. I seem to like that the most in most of my applications when possible. The advantages of going with a single belt is it uses standard gear pitches. It allows for 7 degrees of misalignment, which is a little more of a misalignment factor than what you would see under the FlexiGears, which is about a 5. So it gives you some more misalignment because of the single spline down the middle. It also has greater transverse flexibility, and again, the pitches are .0982 and .10 circular pitches. Now here's looking at the FlexiGear pitch. Again, we have the 32 GCF, the 31 GCF, the 24 and 16, and as you can see, the loads can go anywhere from 30 pounds to 200 pounds of tensile strength. But please remember that even though the tensile strength might be 200 pounds, it's what you need to pay attention to is the recommended operating load, which is 40 to 50 pounds. With that being said, where would something like this in applications be used is things like encoders, certain belt drives that are raising and lowering certain things, and we'll get more into that in the application side of the program later on. Now let's talk about mini pitch. The mini pitch is sort of the miscellaneous of our molded belt series, and what we have here would be the 3TDF, which is the 3D belts. It's one of the few belts in the industry that allows you to go in two separate directions. Most belts are a single plane operation. The TDF allows you to go into two planes, going from to a 90-degree plane. Our belts do allow a slight twist if required, and we definitely ask you to consult the factory when deciding to use these belts in a twist format. By using these molded belts in a twist format or being able to go 90 degrees is something you can't find with, let's say, a timing belt or chain or other kinds of product that's out in the industry or V-belts. Also, we have the 3DCF, which is a triple cable belt, so he gets trying to get more strength from what we're looking at on length there. The Flexi Pitch series is basically our heavy-duty molded belt chain, and what you'll see on those is the pitches are much larger. They're .475, .25, 3/8 and half-inch circular pitch configurations. They are laddered. They are all laddered configurations of the belt. The advantages of going with a lot of those CCF units are again higher capacities of loads. An example is what we see in the next slide, is you show that the load comparisons on the GBF series being 10 to 12 and the CCF being 20 to 75 for the advantages. The nice thing is the DCF, because it's a triple, it increases the capacity to 25, but still uses the small amount of space that you're looking at. Now, when you're dealing with polyurethane belt, the question that I get asked a lot is about belt tension. And the most important thing to remember is when you're talking about belt deflection and making sure a belt is tight in a silent or light-duty chain, is that the deflection should be 1/64th of an inch per inch of center distance. So it becomes a nice gauge to decide how tight that belt needs to be. If not, if you can't maintain that, of course, we should, tensioner would be something that would be recommended in that application if you can't adhere to that a 1/64th per inch of center distance. Okay, now let's get into our timing belt applications. There's two types of timing belts that we're going to talk about. One is the Berg timing belt, which is a light-duty timing belt, and then the standard timing belt, the kind you see like Gates carries, and we'll get into more. The RPMs on the Berg belt is a lot smaller, smaller temperature. Ours are made out of polyurethane. They are spliceable, which is different than standard timing belts. Standard timing belts are molded, and what happens with the standard timing belts is the industry has sort of dictated what those standard belt pitch counts are. So the problem with going with standard timing is that you'll find that you'll get a pitch count that you can't use because the standard timing just doesn't make a belt for that length. That's when the Berg timing belt comes important. Again, we are limited by the capacity of those belts, but it does give you the flexibility in center distances and pitch counts. Again, timing belts are available in either the fiberglass reinforced neoprene or the polyester reinforced urethane. There's no lubrication required. It's a positive drive, and it's a trapezoidal profile for inch pitches. We also carry the HTD profile. That means high tension drive systems. The difference in that profile versus the trapezoidal and the HTD is the HTD is like a half moon. It's sort of like cut down deeper into the sprocket. You have to be aware when a customer is asking about a 5mm belt and a 3mm belt, whether they're asking for a trapezoidal design or they're asking for an HTD design. It could be caught a difference where all of a sudden the customer will get a belt that won't work with the sprockets because he was looking for a 5mm trapezoidal design. Now, one thing that we have found out, or I've experienced recently, is that even though a trapezoidal timing belt is less likely to slip like a V belt is, there is backlash within a timing belt application. And where we see those applications becoming an issue is not in the fine, which is called the 8TB, or the timing belt, which is 0.0816 or an XXL type. We see a lot of the backlash issues of timing belts in the 3/8 and half-inch pitch timing belts, in the sense that the side of the face of the belt is slightly riding up the side of the trapezoid on the sprocket, and you're getting small differences in positional location due to that small amount of backlash. So customers sometimes are coming in and saying, "Hey, I'm buying a timing belt and I'm getting, not a repeatability that I'm looking for." It's due to that small little bit of backlash that could happen within the belt profiles. Timing belts, again, the nice thing about timing belts is you get high ratios are available. High speeds are allowed with the Maxim drives. Those are the form belts. because they're continuously formed belt, these are the Gates type of belts. The advantage is that these belts will take more of the higher power transmissions. They also have longer lives than when I mean a long life. Under normal conditions, you're talking about up to 8 years on standard Maxim drive belts. Available in an MXL, XL, and a 40 DP pitch configurations. And these are the ones that you got to be aware of, because these are the ones that are molded belts. So you have to be careful when you're dealing with pitch counts to make sure that you're dealing with a pitch count that you can actually acquire. Otherwise, you could end up having an undoable system. And again, the important thing about timing belts is that all shafts must be parallel. It's nice to use adjustable centers whenever possible. You got to never force the belt over the pulleys. You got to slide it on. Another nice advantage between the WM Berg timing belts, the polyurethane molded belts, or light duty timing belts, versus the maxi pitch belts, is that with the WM Berg light duty timing belts, there are no shivs that are required for our belts. Because the center cable that goes down the middle allows a cut through on the pulley, it actually becomes a guidepost for that belt to prevent it from walking one way or the other. So you can have pulleys and don't have to deal with the shiv issues that you would have to deal with other timing belts that could walk standard on the standard Maxim drive belt applications. A very popular thing that customers do come to us for is for timing pulley stocks. And what I'm showing you here is our current selection of timing pulleys. What you see is the letter codes, and those are called Gates letter codes. Gates came up with letters for representing all the different pitch counts that are for standard pulleys in the industry. And then what I do is I show the actual pitch diameter. That's the distance of the center of one tooth to the next. And then what lengths we provide that timing pulley in as usable stock standards. We have a lot of machine shops that will come and buy these materials, slice them off, and modify them for their customers' use. So we supply a lot of machine shops with this kind of material. This material is extruded, so what they do is they heat up a billet and push it through an extrusion to get those ridges down the end. That's why they have those little stubs on the ends, is what's left of that extrusion process. Now let's talk about our timing belt and the Power V. Again, our timing belt, the nice thing about us is that it uses standard timing belt pulleys, but our no-walk design eliminates the needs for flanges on the pulleys. We can replace a standard timing belt in certain designs. So if a customer has a timing belt that breaks and they can't get something, or something has to change, they could possibly go to one of our FlexiGrip TB series and use that. Our Power V series is used heavily in a lot of industry, and I definitely view this as an underused type of belt that is out in the industry. The advantage of the Power V series is it allows each link within the V belt to be its own separate unit. So what happens is you can have much greater misalignment between pulleys without worrying about the pulley jumping the sprocket on a V-belt application. Also, the center spline, and on the Power Vs, the center cable runs down the middle and allows each one of the wings of the V to conform. So you can go with a 45-degree V-belt pulley, and you can also use it on a 60-degree belt pulley. You don't have to worry about what the V-belt shiv is. It'll work in any of those shivs. The Navy uses this belt a lot as a repair, quick repair item, and orders it in large quantities. Another example of where this Power V belt is used is on the M1A1 Abrams tank simulators used by the Army. It's used to rotate the turret of the simulators in simulation units. So there's an example of some of the things that we use that Power V belt for. And again, here's showing the Power V belt. And as I stated in the flexible sidewalls, what it does is it gives you that advantage of going to different types of units. And as I've talked about in all of them, if you see up at the very top where the cable design is, you see how our cables are wound and interwound so that there comes in different cable styles. The flexible design of the Power V, again, allows some misalignment within the sprockets that you can't use with other applications. The cog design gives you that kind of flexibility. Now, also, WM Berg also offers a roller chain. The nice thing about our roller chain versus, let's say, our higher plastic molded chain, the polyurethane and nylon chain, is, again, it's a lot quieter. It's a silent drive, no lubrication. That should be zero, not zero backlash. And non-magnetic, rust-proof, and infinite lengths. Our stainless steel chains, though, come in Delrin and Nylotron. Please make sure that when you take a look, and I think it's in the next slide, I'll get farther into it. Our roller chains, again, are available in either stainless steel or carbon steel construction. They can be supplied as an open footage, just an open chain, or in specific continuous lengths. Sprockets we can make in stainless steel, aluminum, carbon, or Delrin material. And our sprockets are available in a 3/16 to a 1/4 inch bore diameters, and available pitches of a .1475, a number 25, number 35, and number 40 chain. We also offer these roller chains in a plastic construction, like I said about the Delrin and Nylotron. They come a snap construction, lengths are adjustable to splice in the field, and they're available in the 1/4 inch, 3/8, and 1/2 inch pitch lengths. We can also provide them with a conveyor and link plate lugs with standard chains. Another thing of our roller chain is it also is pre-stretched. I've never heard a customer come back to us talking to us saying that, with most chains, you'll find a lot of chains that have to be constantly adjusted because as the chain finds its sweet spot, you can gain almost 2 or 3 inches of length, depending on the length of the chain application, as the chain finds its natural set points. Because our chains are pre-stretched, you're not going to find those issues with the WM Berg roller chains. And then, again, the chain comparison. Of course, I was talking about the metal chain and the operating loads for our metal, our mild steels, and stainless steel chains, and showing the strengths of those. But I mostly wanted to show you the difference between the nylon GS and the Delrin, and what kind of applications that there are differences in tensile strength and compressive and also water absorption of these chains to be aware of when in design of these units, because they could have an effect on the engineer's design of what they're looking for, because all plastic chains aren't the same. Again, as I was talking about the steel roller chain, the biggest thing I wanted to point out in this slide is that you have to be aware that because you have a 1/4 inch pitch chain sprocket, you can't run a roller chain on the same thing that you would run, let's say, a 3 CCF or a 7 CCF kind of belt. The reason is because the landing pad, which would be the small area that you see up in the corners where the chain rides, is different on each. So if you've tried to run a let's say a 7 CCF chain on a standard roller chain sprocket, what could happen is the edges on the sprocket could cut the center spines of the ladder chain and cause that chain to weaken quickly over a period of time due to the sharp edges, because there is no landing pad for that chain. Under a roller chain, because that shoulder is much higher on the silent chain sprockets, what could happen is that you're going to have a lot of backlash play and could cause the chain to jump. It'll seem like the chain doesn't fit the sprocket. So if you ever in an application where a customer says, hey, you know, the sprocket doesn't seem to fit the chain, you should always have them check to make sure that how is the chain running? Did we ship the right sprocket, or did they receive the right sprocket, or are they using a competitor sprocket to operate a silent chain? It could be an issue that you could find out that and solve the problem for that customer. Molded belt and chain products. Again, this is a quick overview of all of our chain and belt and chain products. So what you see is you see the pitches for the silent chain up at top, and then we see our roller chains. The RCSS stands for roller chain, with SS stands for stainless steel, without the SS is standard steel chain, and then the D stands for Delrin and N stands for nylon. The next number after all of these would be just the pitch count. And what that is you take whatever the customer's length of chain or belt required. If they're looking for 5 feet, you take that feet, divide it the inches, and then divide by the pitch to get what the part number would be. So if you had a, for example, a 10-inch long, quarter-inch 25 CCF, that would be 4 pitches per piece. So you're looking at 40. So you're looking at 25 CCF-40. That becomes your part number. So it's pretty easy to determine part numbers. And that same part numbering system also falls into the timing belts. Now, in the timing belts down below, you'll see that we have the TB, which is when we're talking with the GT belts, the GT belts are what are called the HTD type of belts. So you got to be careful when you're speccing out the GT belts that you know that the sprockets are not a trapezoidal design. And then you've got your ATBs. Some of the examples of the ATB designs that you'll find out there, and is very common right now, is ATBs using almost always on a lot of these 3D printers, or even printers in your home. You'll see an ATB kind of belt. You'll also possibly see not only an ATB, but also a standard XXL belt is what's the term. We'll call it an XXL belt. So you see all the different sizes that we carry in the HTD lines and the GT lines. We also offer splice kits. The advantage of our splice kits in a lot of our molded belts makes the assembly of these things a lot easier. It'll take a lot of frustration out for the customer to purchase these belt kits. The reason is because we have a spacer block that is a pitch spacer that you see, and what it does is it allows that to lay in there, so when you put the bushings in, all you do is slip the 2 wires in between the bushings and then crimp down. Now, anything that is field splice, that belt is derated by 50%, because here at WM Berg, we do have actual design area where we have pneumatically controlled cylinders that are and pitch spacer blocks that are crimping the bushings to set pressures. When you buy a spacer block kit, you are receiving your crimping tool, your cable cutters, a razor blade, the spacer blocks, and 10 bushings. What you see here is you can buy the bushings in quantities of 10 at a later time. Once you buy the field splice kit, you only have to buy it once, and then once you use those bushings, you just buy the bushings as a separate purchased item. Now let's talk about applications. What you're currently looking at here is plotter heads, printer heads, customer service drawers, fish finder probes. The plotter heads, what you see there, would be an example of something that would be good for that 3TD belt, because now you could see that's a perfect example of where the belt would come over one end, and you could turn it 90 degrees and then actually hit that other sprocket on the other side. That's an example. The printer heads, and the things that you see is these are very quiet. So when you're looking for quiet operation, these are good. The fish finder probe, if you take a look at that YouTube link, this is for a company called Hummingbird. Hummingbird currently is providing for their customers a sonar probe that is mounted on the transom of a boat and drops down approximately 12 to 15 inches below the boat and gives you a 360-degree view under the water of every obstacle on a screen that's mounted on the boat. It's almost cheating when it comes to fishing. Other operations, again, so I talked about the 3D printer gantry, and here's an example of our window shade designs that are currently used in the industry, and you can see how the belts are used for raising and lowering the shades. Other applications, you could see this also be used in things like boat companies. You could see it used in other aircraft. A lot of also this belt is used on remote-controlled vehicles for driving. We've seen it used on remote-controlled steering applications where they run these back and forth to drive units. So there's a lot of applications for this lightweight, light design application systems. If you have any questions, feel free to contact me here at WM Berg. You've got the tech support line or phone number. At this time, are there any questions that anyone has? I'd be glad to take them. If not, then I'd like to thank everyone for coming today to WM Berg's presentation on belt and chain design and drives. Thank you very much for coming. We'll see if this, if we get a positive response on this, we'll have this out in the future. So again, thank you very much for your time today, and I appreciate your coming on WM Berg's presentation on WM Berg belt and chain drives. Thank you.